students, in this lecture let us learn about simplification of Boolean expressions. Already you have studied simplification of Boolean expressions using laws, rules and De Morgan's theorem in the first year electronics. Let us see some of the rules here. The first rule, a plus a bar is equal to 1. A variable and its complement added together is equal to 1. The second rule, a variable and the same variable add together, that is equal to a. That is a plus a is equal to a. The third rule, a into a variable multiplied by same variable is equal to a variable a only. The fourth rule, a into a bar is equal to 0. Next, a plus 0 is equal to a. A variable add with 0 is always equal to a variable a. Next is a plus 1. A variable add with 1 is equal to 1. Next one, a variable multiplied by 1 is equal to a variable a. The next rule, a into 0. 0 is multiplied by anything is always equal to 0. The next rule, a into b is always equal to b into a. This is also called as commutative law of multiplication. A into b is equal to b into a. The next law is a plus b is always equal to b plus a. For example, 0 plus 1 is equal to 1 plus 0, that is equal to 1 only. The next one is b into a plus a bar is equal to b. Here apply the rule number 1, a plus a bar. A plus a bar is equal to 1. Substitute this one in place of a plus a bar. So that is b into 1 is equal to b. By using rules we can simplify the expressions. The next one is a plus ab is equal to a. In this expression, see the first term and the second term. In these two terms, a is common, take it outside. The remaining from this expression is 1 plus b. According to rule, 1 plus b is equal to 1. Substitute 1 here. So a into 1 is always equal to a only. The next one is a into a plus b is equal to a. Here multiply a with a and b. A into a plus a into b. Apply the rules here and that is equal to a. The next one is De Morgan's theorem. We have two De Morgan's theorem. The first theorem says that sum of complement is equal to product of individual complement. That is De Morgan's first theorem. The second theorem, product of complement is equal to sum of individual complement. These are the rules, laws and the De Morgan's theorem for the simplification of Boolean expressions. Using these rules and laws, we can simplify the Boolean expressions. Along with these rules, we have some important terms. The first term is product term. Already you have studied. The product term is nothing but logical AND function. AND function is multiplication of variables. Here the variables may be complemented or uncomplemented form. For example, a into b bar into c. Here a is uncomplemented form, b is complemented and c is uncomplemented form. So product term is nothing but multiplication of variables. The second one is sum term. The sum term referred as logical R function, that is nothing but addition of variables. Here also the variables may be complemented or uncomplemented form. For example, a plus b bar plus c. Here a is uncomplemented, b is complemented and c is uncomplemented form. The next term is sum of product. It is an abbreviated form of SOP. Here several product terms are added together. For example, A bar B bar is the product term, B bar C is the product term, A bar C bar is the product term, A B C bar is the product term. These many product terms are added together, that is called SOP. So here the variables may be complemented or uncomplemented form. This next one is product of sum. It is abbreviated as POS form. Here several sum terms are ANDed together. It is multiplication of several sum terms. Here the sum terms are A plus B bar plus C, one sum term, A bar plus B bar, second sum term, third sum term is A plus B plus C, and the last one is A bar plus C bar. These sum terms are multiplied together. So that is the product of several sum terms. The next one is canonical SOP. So canonical is the standard form of SOP. Here also several product terms are added together. It is addition of several product terms. Here the variables are complemented or uncomplemented form. In this example, A bar B bar C is a product term, A bar B bar C bar is the second product term, A B C bar is the third product term. So this product term is also called as minterms. So here all the variables must be present. It may be complemented or uncomplemented form. Now see the difference between SOP and POS form. In the SOP, in the first term, the variable C is missing. In the second term, variable A is missing. In the third term, the variable B is missing. So it is simple SOP form. But in the canonical SOP, all the variables must be present. In the first term, A, B, C, three variables are present. In the second, three variables are present. And the third also, three variables are present. So the difference between SOP and canonical SOP, in the SOP some of the variables are missed out, but in canonical SOP all the variables must be present. That is the difference between SOP and canonical SOP. The next one is minterm. A minterm is nothing but logical AND function. It is a special logical AND function. Why it is special? In this, all the variables must be present. In the simple AND function, some of the variables may be missed out, but here all the variables must be present. In the canonical form, each product term is called as minterm. See the canonical expression here. The first term is A bar B bar C. The second term is A bar B bar C bar, and the third term is A B C bar. In this product term, all the variables must be present. Each product term is called as minterm. So the minterm, the first minterm is A bar is 0, B bar is 0, and C is 1. So this is nothing but minterm M1. The minterm is always represented by small letter m. So M1 is the minterm of a first product term. The second one is A bar, B bar, C bar. A bar is 0, B bar is 0, C bar also 0. 0, 0, 0 is nothing but M0, minterm 0. The third product term A, B, C bar. A is 1, B is 1, C bar is 0. 1, 1, 0. This is called minterm 6, M6. And here the each product term in canonical SOP is called as minterm, but it is not in the SOP. The next term is canonical POS. It is a standard product of sum term. So here several sum terms are multiplied together. So that is called canonical POS. In this, The sum term, see the sum term, all the variables must be present in each sum term. The first term a plus b bar plus c. In this all the variables are present, a, b and c. The second sum term, the variables a, b, c, all the variables are present. A is complemented, b is complemented and c is uncomplemented. In the third sum, all the variables are present, a plus b plus c. In the fourth also, all the variables are there, a bar plus b plus c bar. So in standard POS, all the variables must be present in each sum term. Difference between POS and canonical POS. In the POS form, the first sum term all the variables are present. In the second sum term, the variable c is missing. In the third one, all the variables are present, but in the last one, the variable b is missing. So in the POS, it is not compulsory for all the variables, but in canonical POS, all the variables must be present. In the first term, a, b, c, 3 variables are there. In the second also, a, b, c, 3 variables. Third, a, b, c, 3 variables, and last also 3 variables a, b, c. So in the canonical POS, all the variables must be present. The next term is Maxterm. So each sum term in canonical POS is called as Maxterm. So it is a special sum term. The sum term a plus b bar plus c is called as Maxterm. And the second a bar plus b bar plus c is called as Maxterm. Each sum term in canonical POS is called as Maxterm. In this example, a is 0, b bar is 1 and c is 0. 0, 1, 0 is nothing but M2. The second sum term a bar is 1, b bar is 1, c is 0. So 1 plus 1 plus 0, 1, 1, 0 is M6. The next one is a is 0, b is 0, c is 0. So this is M0. The next one is a bar is 1, b is 0, c bar is 1. That is 1, 0, 1 is called as M5. Maxterm is represented by capital letter M. The next is Minterm designation. This Minterm designation is only for 2 variables. The variables are a and b. So for example, a is 0, b is 0. So this is called as a bar into b bar. So see the a column. In the a column, a is 0. 0 is called as a bar. B column is also 0. That is called b bar. If it is 0, take complement of that variable. That is a bar into b bar. The Minterm designation is M0. 0, 0 is called as 0. So the Minterm designation is M0. The second one is a column is 0, that is a bar, b column is 1, that is b. The multiplication of these 2 variables is a bar into b. The Minterm designation is M1. 0, 1 is called as 1, so the Minterm designation is M1. The third one is a is 1, that is a, b is 0, take complement of b, that is b bar. So a into b bar is the product term and the Minterm designation is M2. 1, 0 is called as 2, so the Minterm designation is M2. The next one is a is 1, a column is 1, that is a, and b column is 1, that is also b. So 1 and 1 is a into b. The product term is a into b. The Minterm designation is M3. So this table is Minterm designation for 2 variables a and b. Let us see the 3 variables Minterm designation. The 3 variables are a, b and c. The first term a is 0. If it is 0, take complement of that. A complement is a bar. B also 0. Take complement B bar, C is 0, take complement C bar. So the product term is A bar into B bar into C bar. The minterm designation is M0. 0, 0, 0 is called as 0. So the minterm designation is M0. The next one is A column is 0, B column is 0 and C column is 1. So the product term is A bar, B bar, C. The minterm designation is M1. In binary number 001 is equal to 1. So the minterm designation is M1. The third one is A is 0, B is 1, C is 0. So A bar, B, C bar. A bar, B, C bar is the product term of 0, 1, 0 and minterm designation is M2. The next one is A is 0, that is complemented one, A bar, B is 1 as it is B only, C is 1 again C only. So the product term is A bar, B into C. The minterm designation is M3. The next input is A is 1, that is A only, B is 0, take complement of B, that is B bar, and C also 0, take complement of C is C bar. So the product term is A into B bar into C bar, that is nothing but M4. And next one is A is 1, B is 0 and C is 1. So that is A, B bar, C. So A into B bar into C is the product of 1, 0, 1 and the minterm designation is M5. The next one is 1, 1, 0. If it is 1, take as it is. Take the variable as it is, A only, and the second variable B and the third variable is complemented. The product term is A into B into C bar. The minterm designation is M6. The last one is all the variables are 1, 1 and 1. A is 1, B is 1 and C also 1. The product term is A into B into C and the minterm designation is M7. So this is the minterm designation of 3 variables. Now let us see the conversion of SOP into its canonical SOP. So here convert y is equal to AC plus B into C bar into its canonical SOP. First, identify the missing variables. In the first product term, the missing variable is B and its complement B bar. So see the second product term. In the second product term, the missing variable is A and its complement. First multiply the missing variable and its complement. So AC into B plus B bar. In the second term, BC bar into A plus A bar. First step is identify the missing variables, multiply the missing variable and its complement. Next, that is equal to A into B into C, A into B into C plus A into C into B bar, that is A into B bar into C, plus B into C bar into A, that is A into B into C bar, plus B into C bar into A bar, that is A bar B C bar. Now see the product term. In each product term, all the variables are present. A, B, C, A, B, C, A, B, C and A, B, C. So each product term is also called as minterm and the product terms may be complemented or uncomplemented form. But the thing is, all the variables must be present in each product term. Let us see the second example. The y is equal to AB plus C into its canonical SOP. In this, in the first product term, A into B, here C is missing, C and its complement, C bar is missing, multiply C and its complement. In the second product term, only C is present, so multiply two variables A and B. In the first term, multiply A and its complement A bar. Now the expression is A into B into C plus A into B into C bar plus A into C, that is AC, and the missing variable is B. So multiply B and its complement. The last one is A bar into C. A bar into C. Again here B is missing. Multiply B and its complement B bar. Now A into B into C plus A into B into C bar plus A into C into B is ABC plus A into C into B bar is A B bar C plus A bar into C into B is A bar B C plus A bar into C B bar is A bar into B bar into C. Now check the repeated variables. If any product terms are repeated, take only one time. So in this expression, A into B into C, A into B into C, two times are there, so write only one time, take only one time. So that is ABC, ABC plus A into B into C bar plus A into B bar into C plus A bar into B into C plus A bar B bar into C. In each product term, check the each product term. In each product terms, all the variables must be present. So here ABC, three variables are there. In the second ABC, 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 and the last also ABC. The variables may be complemented or uncomplemented form. Convert y is equal to a plus b into a plus c into its canonical POS. Here in the first sum term, identify the missing variables. A plus b, here the missing variable is c and its complement. See the second sum term. In the second sum term, a plus c, here also the missing variable is b into b bar, a variable b and its complement. Next, add the missing variables and its complement to each sum term, that is a plus b plus c into c bar into a plus c plus b into b bar. Now apply this rule. According to this rule, a plus bc is equal to a plus b into a plus c. So in this example, in this expression, this a plus b is assumed this a plus b as a and c into c bar as bc. According to this, a plus b plus c into c bar is equal to a plus b plus c into a plus b plus c bar, that is a plus b plus c into a plus b plus c bar. See the second sum term. So this is looks like A and this is looks like B into C. So according to this rule, A plus C plus B into A plus C plus B bar. That is the expression, the sum term A plus B plus C into A plus B bar plus C. Now identify the repeated variables. In this expression, the repeated variables are a plus b plus c and a plus b plus c. So there are two times, write it only one time, that is a plus b plus c into a plus b plus c bar into a plus b bar plus c. So this is the final expression of canonical POS. See the each sum term. In each sum terms, all the variables are there and variables may be complemented and uncomplemented form. Thank you.